Good afternoon, all. Today, this video is going to be on perimeter area and volume ratios in similar figures. Just going to show you the connection between the ratios. Not daily on the connection between the ratios, and then we'll go through some examples on how to find areas, find perimeters, etc. So initially, if you have similar figures and they have a ratio of similarity, I'm just going to use it in terms of x and y for right now. So this would be x over y. The ratio of the perimeters is always going to be the same as the ratio of similarity. So these are always going to be the same. The ratio of the areas, I should have areas here. The ratio of the areas is going to be, excuse me, when you square both of those values. So it'll be x squared over y squared. And the ratio of the volumes will be when you cube both of those values. Both of those values. There it is. So it'll be x cubed over y cubed. So I'll just give you a simple enough example, and we'll just do an example of, do that one example for each one. So if I gave you a ratio of similarity of 2/3, then the ratio of the perimeters, according to our similarity ratios here, would be the same. It would still be 2/3. The ratios of the areas would be squaring both of those terms. So it would be 2 squared, which is 4. I'll just write it out. So it'll be 2 squared, which is 4, over 3 squared, which is 9. And then lastly, if it's the volumes, it'll be the values cubed. So 2 cubed is 8, and 3 cubed is 27. So these would be those specific ratios. All right, so the first thing I have here as far as some practice is just going to be completing this table using the ratios of similarity, perimeters, areas, and volumes. And then underneath I have a few like word problems. So I'll just once again write up here what the ratios are. Similarity would be x over y. Perimeter is also x over y. Areas is x squared over y squared. And volumes is going to be x cubed over y cubed. All right. Okay, so for the first example here of the table, the ratio of similarity is 3/4. So similarity and perimeter are the same, so this would also be 3/4 for the perimeter. The areas would be 3 squared over 4 squared. 3 squared is 9. Excuse me. And 4 squared is 16. Volumes. We would cube both of those terms, so it'll be 3 cubed. 3 cubed is 27. Down the script. Oh, sorry, hold on. What is that little dot? I don't know. Sorry. 27, and then on the bottom, the 4 cubed is going to be 64. All right, next. For the next one, I'm starting with the perimeters. So we have to go, backwards, so to speak. So if you're starting with the perimeter, excuse me, the similarity ratio is again the same, so it's just 7/8. The area ratio is going to be 49 over 64, squaring both of those terms. And then the volume ratio is cubing both of those terms. So 7 cubed, I think, is 343. Oh, what did it say? Divided by 3. Yeah, 343. And 8 cubed, I think, is 512. Yes. Should have on my instincts. All right. For the next one, I'm starting with the areas. So if you want to go, excuse me. So if you want to go backwards from the area ratio to we should always just go back to the similarity. That means we need to take the square root because we squared it to go this way. So to go backwards, we're going to square root it. So the square root of 25 is 5. And the square root of 49 is 7. And again, you can do that on your calculators, phones, whatever if need be, but hopefully you do know some of your basic squares. All right, so that means that the ratio of the perimeters would be the same, 5/7. And the ratio of the volumes would therefore be 125, because that's 5 cubed. Because again, we're going from here, there. So 5 to the third power, uh, excuse me, 7 to the third power, we just said was 343. So that would be our answer. All right, next example, the fourth row here. You're starting with the volume. So just like when you started with the areas, to go backwards, we square rooted. When you're going backwards from the volumes, we're going all the way back here, we have to cube root. In your calculators, you'll see a button that looks, you'll see a button that looks something like this. It's an X and then it's like that. You have to play around with it to figure out how to input your answers. Some calculators, you put the number first. Excuse me. That's something you're going to have to figure out with your particular calculator. But we want to take the cube root. So if you just do the regular, that's incorrect because then you'll get 8. That's not what we want. We don't want the square root. We want the cube root. We want to know what cubed gave us 64. So we're doing the cube root of both of these. And the cube root of 64 is 4. And the cube root of 729 is going to be 81. I'm sorry, it's 9. I'll say 81. All right, so once you figure out this, that means the perimeter is the same. It's 4/9. And the area is going to be 16 over 81. Because now we're squaring these to get that. For the next example, I'm starting with the perimeter, which means that the similarity is also 1/3. They're the same. The area would be 1 over 9. Just wanted to do this one with the 1 because there's still a lot of people, when you square 1, you put 2. Again, be careful. 1 squared means 1 times 1, so it's still just 1. And then for the volume, it would be 1 cubed, which is again still 1. And then the 3 cubed would have been 27. All right, now the last two are of the same caliber, but if you just do what we did for, I think that was the fourth example, and we just take the cube root, you're going to see that these are going to give you decimals. None of these values that you're going to see in any of the tables on a future quiz, exit card, or anything like that will be something where you should have a decimal. So if you put the the cube root, of 16, you would get like 2.51, etc. 2.519. And then if you do the cube root of 54, you're going to get 3.779, etc. God, this yawning. That'll never be accepted as an answer. I never want any decimals. So if you get decimals when you take a square root, if you get decimals when you take a cube root, you probably could have done something else first. That something else you could have done would have been simply to reduce this. So if I erase this nonsense and I just reduce it first, if I reduce this, I could get 8 over 27? 8 over 27. Now I'm going to try to take the cube root again that I've reduced it. If you get some type of crazy decimal, it's probably a situation where you should have reduced first. So now I'm going to try again to take the cube root. The cube root of 8 is 2, and the cube root of 27 is 3. So our answer is 2/3. Again, if you get decimals, erase, start again, you should reduce first. So the perimeter is also 2/3, and the area ratio is going to be 4/9 once we square 2 and we square the 3. All right, and then the last example here for the table is an area example, and it has a ratio of 16 over 36. If you want to go from area to similarity, we should be square rooting it. If we square root these, we would end up with 4/9 for our answer. We could have reduced this out first, though, and that's why that would not be. Oh, I'm sorry, it wouldn't be 4/9. It would be 4/6. Sorry about that. This would be 4/6. Um, and at this point, we can reduce it, but you could have also reduced it in the beginning. With the 16 and the 36. But luckily, these are still perfect squares, so it didn't matter that you didn't reduce it at first. Again, you just want to make sure everything is reduced. Don't put 4/6 here and 4. You want everything. Any of your ratios should always be in their simplest form, in their reduced form. So our answer is going to end up being 2/3 here. And again, the perimeter and the similarity are the same, which therefore means this would be the same as what it was here, which is 8/27 when we cube them. All right, so the next few things we're going to do is just look at some examples as to how these ratios would be applied. Alrighty, so for the first example here, it says two similar polygons have corresponding sides in the ratio of 5:7. What is the ratio large to small? That's important, so make sure you always check that. If it doesn't say in a problem, then obviously it doesn't matter. But if it specifically says like small to big or big to small, you need to make sure you're following the request. All right, so what is the ratio of the larger to the smaller of their perimeters? Gosh, sorry about this. So it's going to be the same. I'll write it, I guess, with the dots. So again, for the perimeter and this, it's the same. Only reason we're switching it is because it specifically says large to small. What is the ratio larger to smaller of the areas? So areas would mean we would have to square that. It would be x squared over y squared. So it's going to be 49 over 25. What is the ratio larger to smaller of their volumes? So again, volume is when we cube it. So that would end up being 7 cubed, which we said was 343, and 5 cubed is 125. Okay, now the next example, it says the area of the smaller regular polygon is about 27.5 centimeters. So let's just be clear that that means this is the smaller one, this is the area of it. It says, what is the best approximation for the area of the larger regular pentagon? So this is the question, basically. All right. So what we want to do is start off with the ratio of similarity. The ratio of similarity is 4:10. Now, again, I could keep it there, but I always want smaller numbers if I can. So I should, because this isn't the answer. Like if the answer was just asking for the ratio and you didn't reduce it, it's wrong. But as far as for calculations, you don't have to reduce it until the end. So I'm going to go ahead and reduce this to 2/5. So if that's my regular ratio of similarity, that means that my area ratio is going to be, cross it out, this squared. So it's going to be 4/25. So for my area, it's going to be 4:25, as this is the ratio of the smaller triangle. I'm sorry, of the smaller pentagon. So this is going to be 27.5 up top, x on the bottom, and then we cross multiply and solve. 4x equals 25, 27.5. We get 687.5. Divide that by 4. We get x equals 171.9. All right, and 171.9, it says what's the best approximation? So our answer would be C. All right, you guys try 2A. Pause the video for a second and see if you guys can figure that one out on your own. All right, so hopefully you guys gave it a try so far. The ratio of similarity is 3/4, which would hopefully everyone could figure out the ratio of the areas. Should be 9/16. Now, it says here that the area of the larger parallelogram is 96. The larger one is down here, so that means I want to make sure my 96 is at the bottom. Be careful, a lot of you just immediately put it at the top all the time, and that would have given you a wrong answer. And then we put our x here. And again, we cross multiply and solve like we do any proportion. So it's 16x equals 9 times 96. It's 864. And divide that by 16. The answer is 54. What is this? And we would say inches squared would be the area. All right. The next example, 2b, is kind of similar, a little different. This one says two similar figures have an area ratio of 8 to 50. The volume of the smaller figure is 200. What is the volume of the larger figure? So this one's a little different. I'm starting you off with the area ratio and telling you that's 8 over 50. Again, 8 over 50, I would get, hopefully you guys know if I took the square root, I'm going to get decimals. So that's not going to help me. So what I want to do first here is reduce this. I can reduce this by 2, and I end up with 4 over 25. So now these are much more recognizable as perfect squares. So that means my ratio of similarity would be 2/5 if I took the square root, square root. Now, this is not the ratio that I'm using for this problem though, because it says volume. So I have to figure out what my volume ratio is, ratio of the volumes. So 2 cubed is 8, 5 cubed is 125. And now that I have my volume ratio, I'm going to put in which of the volumes I know. I know the volume of the smaller figure is 200. So this is 200 here, because that's where the smaller figure is. X at the bottom. I'll end up with 8x equals 125 times 200. I get 25,000. And I divide that by 8. My answer is 3,125. And I didn't put any units, so no need to worry about that. Alright, and this next one is a little bit more elaborate, but you do want to practice like a word problem here and there. During the summer, a group of high school students cultivated a plot of city land and harvested 13 bushels of vegetables that they donated to a food pantry. Next summer, the city will let them use a larger, similar plot of land. In the new plot, each dimension is 2.5 times the corresponding dimension of the previous plot. How many bushels can the student expect to harvest this year? All right, so I would figure out what my ratio of similarity is, which they already wrote here for you, would be 2.5 to 1. That would mean I could figure out what the ratio of my areas is going to be by squaring this. So 2.5 squared is 6.25. And 1 squared is 1. So once you figure out your area ratio, you know that it's going to be like 6.25 times more than what you had last year. So if you have that much more area, that much more space, then you would expect to harvest that same proportion more of vegetables. So that's where the 16.25 times 13 comes from there to get the answer. All right, so let's try with the similar situation here. It says the scale factor of the dimensions of two similar pieces of window glass is 3 to 5. A smaller piece costs $2.50. How much should the larger piece cost? All right, so those are the dimensions. The smaller piece costs $2.50. How much should the larger piece cost? So when it comes to like a window glass, it's using area, like basically to figure out the size of it. You need to know the length and width of it. That's how the price is configured. So you do, even though it's not obvious, you do need to find the area ratio here. So it's going to be 9. I shouldn't put equals. It's going to be 9 over 25 equals. and then the smaller piece was 250. The larger piece is going to be x. 9x equals 25 times 250 is 6250 divided by 9. The larger piece is going to be about 694. Reasoning in problem 3, why is it important that each dimension is 2.5? Well, it's important that each dimension is 2.5 times, so it's not just like one side that's being doubled. If only one side was being doubled or times 2.5, then they wouldn't be similar. So let's just explain that. So let's say this was 1 and this was 2, and I only multiplied this side by 2.5 and left this as 2, then the sides wouldn't be similar. It would be 1 to 2 as 2.5 is to 2, and it wouldn't work out. So it would only work if each dimension had that property. All right, got like 2 more examples here, maybe 3, and then we're done. This one, I'm giving you the area ratios. They're 50 to 98. Again, area ratio. Hopefully you recognize that those are not perfect squares. If you didn't, again, just try your calculator to the square root of square root of 50. You'll see that you'll get a crazy decimal. So that means you should be trying to reduce this first. This can reduce to 25 over 49, which means that the ratio of similarity is going to be square root of that, so 5/7. And since the ratio of similarity is 5/7, that's also the ratio of the perimeters. All right, next problem. The area of 2 similar rectangles is the following. What's the ratio of their perimeters? So 1875 over 135. Area ratio. So again, you can just immediately try to do the square roots, but hopefully just because these have 5s here, you do realize that it can be reduced. So I'm going to do 1875 divided by 5, which is 375, and 135 divided by 5, which is 27. All right. I know 27 isn't a perfect square, so that means that I can still reduce this, or I would have to in order to not get a crazy decimal. So I know what goes into 27 is 9 and 3, so I'm going to try 9 first because it's bigger. That didn't work, so I'm going to try 3. All right. So 3, this is 125, and this is 9. So now I have this down to something that I can try to take the square root of on the bottom, but the top is still not going to give me a whole number. So unfortunately, I'm going to do this one in radical form, which I know most of you guys love to hate. So the area of similarity is going to be the square root of 125 over the square root of 9, because I need to take the square roots. That's going to end up being 5√5 over 3. And therefore, the perimeters would be the same. Sorry, I forgot it was perimeter. And I think that's it. Yeah, after that, it's just some examples. Have a good day, guys. Do some of the practice. Take some notes.